Okay, so, anyways, today I'm gonna explain the sliding filament theory. This was Fang's first lecture of Forming Function 3. So we only have two objectives in this lecture, which is to explain the muscle contraction with the sarcomeres and whatnot, and then explaining the cross bridge cycle. So first, a sarcomere is from Z line to Z line. That's what a sarcomere is. And then the Z line itself attaches the actin filaments, and then the I band is just going to be that zone that only has the actin. And then the M line, M for myosin, that's going to anchor your myosin filaments. And then again, you have an H zone, which is just that area with the myosin filaments. And then the very last zone is the A band, which is the zone with both actin and myosin. So then an easy way to remember that is zebras in my house always. So zebras in my house always. Z is for the Z line, which is the anchor, and then the I tells you what is in that anchor. Then the M line is the anchor, and then the H zone tells you what is in that anchor. And then the A is just both actin and myosin. And then during that contraction, the actin is going to get pulled by the myosin. If I'm myosin, I'm pulling actin and I'm putting it over me. That's cuddle. Then you're going to be pulling that towards that A band. So myosin is going to pull that actin towards the center of that A band. So then what would happen to each of these areas during that contraction? So then the Z line, this sarcomere is contracting, so each Z line is going to move closer together. And then that I band, you can imagine if this is all contracting, that's going to narrow. Then the M band and this A band, these two are going to remain basically unchanged. But this H zone, remember, was the area with just the myosin. Since myosin is pulling actin on top of it, that's going to disappear. There's not going to be an area with just myosin. Then that covers the first objective. The second objective for this exam, for this topic, is the cross bridge cycle. So you're going to have a thin actin filament, and then you're going to have the myosin thick filament. This is explaining how myosin does this whole pulling actin on top of itself. So first, that cross bridge, which is just the myosin heads, that cross bridge is going to have ATP bound to it. That's what's going to allow the actin filament to relax the muscle. But once ATP goes through hydrolysis, which is when it divides into ADP and then inorganic phosphate, that is going to allow the cross bridge to find its binding site and attach to it. Once that inorganic phosphate releases, that's going to tell that cross bridge to create the power stroke, which is going to actually contract that muscle. In this area, once you have that power stroke and you're contracted, if the animal is dead, it's not going to create more ATP. So all of the muscles are going to be contracted, and that's when you have that rigor mortis, just stiffness. But we're alive, and that animal is alive, so it's going to create more ATP, and then that ATP is going to bind once again to relax the muscle, and that's when ADP is going to release, ATP is attached, then it relaxes. And then, this is just everything I just said, but I'm writing. The last thing is the fun fact for the topic is that phosphocreatine is the shortcut way to create that energy supply that you need when you have sustained muscle activity. If you don't have enough ATP because you're doing too much exercise or that dog is running around in the backyard when it's not supposed to be, phosphocreatine is how it's gonna get the energy that it needs in that moment while it's peeing.